All right, U9D3. We're going to be solving some exponential equations, some basic exponential equations here, okay? So in order to solve these things, we need to use a property of exponents that tells us if we have something like this guy right here, x to the m equals x to the n. If the bases are the same and those two sides are equal, then that means the exponents also have to be the same, right? So like example like this, if we have 3 to the x equals 3 to the 25th, since those bases are the same, that also means the exponents have to be the same, right? So x has to be 25, right? Something like this over here too, same thing. 0.25 to the 1/2 equals 0.25 to the x. The bases are both 0.25, so the exponents also have to be the same. So x has to be a half, right? So what we're going to do to solve these is our goal is to make the bases the same, if possible, so that we can actually set the exponents equal and solve it that way, okay? So first thing is we're going to practice making the bases the same. So in these it says convert the numbers to the same base if possible. So what we're looking at here, 36 and 2/16. So we got to think about, can we rewrite 36 as something raised to a power? We can. We can rewrite 36. We can rewrite 36 as 6 squared. Okay, so then we've got to check and see, since we could rewrite that as 6 squared, can we rewrite 2/16 as 6 to a power, which 2/16 is actually 6 to the 3rd. So we can convert those to be the same base. Okay, that's going to be the goal when we're solving these equations. Same thing with 2. 25 and 125. We can rewrite 25 as 5 squared, and 125 we could rewrite as 5 to the 3rd. So we can rewrite them as the same base, right? Number 3, 8 and 64. There's actually 2 ways you could go about this one. So 8, we could say that's just 8 to the 1st power. And then 64, we could rewrite as 8 squared. So we could do that. Or, right, we could say 8, we could rewrite 8 as 2 to the 3rd power. And then 64 is 2 to the 6th power. So either way you see it there is perfectly fine, okay? Now, number 4, the square root of 8 and 1/2. This one's a little bit tougher. So remember with this, the square root of 8, we can change that to a rational exponent. So the power is 1, the index is 2. So we could rewrite this as 8 to the 1/2. Okay? And then we can work with 8 and say that 8 is 2 to the 3rd power. And then we've still got that 1/2 here. So this would be power to a power, so we're going to multiply. So we could say this is 2 to the 3/2 if we wanted to, right? Now as far as 1/2, right, remember this is just 1/2 to the 1st. And if we want it to be base 2, we need to take this and shift it up in the numerator. So to do that, we just change its sign. So 2 to the -1st and 2 to the 3/2. Now the bases are the same, okay? Number 5, 4 and 20. If we think about 4, we can rewrite that as 2 squared. And then 20, we got to say, can we rewrite 20 as 2 to a power? Which we cannot. So we can't write these as the same base. Okay, so nothing to do with those. Last one of these, number 6, 27, we could rewrite as 3 to the 3rd power. And then 1/9, we could say that's so 9 would be 3 squared. And again, we want base 3. Instead of, this is 1/3, we want base 3. So we need to take this and shift it to the numerator. So that's just going to change that sign. Make it 3 to the 3rd and 3 to the -2nd, right? So again, goal here is to rewrite both sides of these equations like we just did, okay? So in number 7, to solve these exponential equations, we got 5 to the x plus 2 equals 5 cubed. So if we check this guy out, our base here, they're both already the same. So since our bases are the same, that means our exponents also have to be the same. So we can just take that, basically drop the bases, and say our exponents have to be equal. So if we subtract, we get x equals 1. Okay? And number 8, if we look at our bases, we've got 7 and 49. Those are not the same base. So we've got to convert, try and see if we can convert one or both sides so that we have the same base. We can't do anything with the 7, but 49 we can rewrite as 7 squared, right? So now both bases are 7. They're equal, so that means our exponents have to be equal. So again, subtract, we get x equals 1 again. Okay? Number 9. 8 to the x plus 2 equals 64. So again, bases are not the same. So we check, can we rewrite 64 so that it's a base 8? We can. We can rewrite 64 to be 8 squared. So now again, both bases are 8. So our exponents also have to be equal. So subtract, this time we get x equals 0. Okay? In number 10, right, we've got 5 to the 3 minus 2x equals 5 to the negative x. So bases are equal, so that part's already done. So we can set the exponents equal. Okay, so get your variables on the same side, add this 2x over. So just get x is 3. Okay, let's see, 11. Those bases are not the same, so we can't do anything with the 3. So we've got to check, can we rewrite 81 so that it's 3 to a power? 81, let's see, that'd be 3 times 3 is 9, times 3 is 27, times 3 is 81, so it's 3 to the 4th. So now the bases are the same. So we set them equal. 1 minus 2x equals 4. So then solve. And then divide. So x equals negative 3/2, right? And then for number 12, right, bases are not the same. 27 to the x equals 1/9. So we got to figure out what base we can rewrite both of these in. So 27, we could rewrite as 3 to a power. We could rewrite that as 3 to the 3rd, right? But that is still being taken to the x power, okay? And then so we got to figure out, can we rewrite 1/9 as 3 to a power? So 9 would be 3 squared, okay? Over here on the left side, we have a power to a power. So we're going to multiply those powers, 3 times x. And on the right side, we want base 3, not base 1/3. So we've got to take this guy and shift it up, which is going to change that sign to -2. And now our bases, they're the same, so our exponents have to be equal. So 3x equals -2 divided by 3. X is -2/3. Okay? So to solve these, again, our goal is to make the base on both sides the same. That's what we're trying to do, all right? And then the last few here, it's going to be basically the same thing, except now we're dealing with inequalities. So we're supposed to solve and then write our answers in graph and interval notation. But it's the same process as what we just did, okay? So trying to make both sides be the same base. So in 13, we can rewrite this 49 to be 7 squared. So 7 squared, right? And then that's being raised to the x minus 1 power. So to work with this, right, we have a power to a power. So we need to take 2 times x minus 1. Okay? And now that our bases are the same, our exponents also have to be the same. So we're going to go 4 minus x is greater than 2 times x minus 1. and we're going to solve this. So we got to distribute, get our variables on the same side. Add this 2 over. So we got 6 is greater than 3x, and then divide by 3. So we got 2 is greater than x, right? Which is the same thing as saying x is less than 2. So as we graph, right, less than, so open dot at 2, less than 2 would be to the left. And then our interval, it's coming from negative infinity, and then it's going to 2. Okay, so that's what we're working with there. And 14. 125 to the x minus 3 is less than 5. So this side over here is 5 to the first, so we need to see 125. We can rewrite as 5 to the third. Okay, so again, we're going to multiply. So we'd have 5 to the 3 times x minus 3. It's less than 5 to the first, so now that they're both base 5, we're going to go 3 times x minus 3 is less than 1. So distribute. Oops. So it'd be 3x minus 9 is less than 1. Add your 9. Divide by 3. So x is less than 10 thirds. Okay, so open dot at 10 thirds. Less than that is to the left. Going from negative infinity up to 10 thirds. Okay, and then our last one, 1/4 to the 2x is greater than or equal to 8. So we got to think about what we can rewrite these things as. 8, we can say is 2 to the third power. And then 1 over 4, 4 can be 2 squared. Okay, but again, we don't want base 1/2, we want base 2. So we've got to take this guy, shift it up to that numerator. That would make it 2 to the negative 2 to the 2x, greater than or equal to 2 to the third. So we take power to a power, so multiply. So now that our bases are the same, that would be negative 4x is greater than or equal to 3. So if we divide by negative 4, right? This is the one thing we got to remember when we're dealing with inequalities. We divided by a negative number here. So that means we got to flip the symbol. So this would become x, and then we flip that symbol, less than or equal to negative 3/4. So close dot for the or equal to, negative 3/4. Less than that would be off to the left. And then we're coming from negative infinity going to negative 3/4. And since it's a closed dot, we put a bracket there. Okay? So again, whole goal of these is to make both sides have the same base, so we can just basically eliminate the bases and just worry about the exponents. Okay? So try out your homework. Let us know if you have any questions.